Welcome back. We're still working on critical points here, so this is example number 3. And we have this function here, x cubed minus 8 raised to the 2/3. So the first thing I did is I always like to graph it and kind of look at it because we're looking for critical points. So I did graph this on the graphing calculator, and this is what our graph looks like. It is this little function here, and it looks a little weird here. It's coming down like right here, and then it has this, like, it looks like a slope of 0, comes to a real sharp point, and then here. And the one thing I want to remind you is, even though there may be no derivative there, you could still have a critical point even where the derivative doesn't exist. And this looks kind of like right here, it looks like the slope is 0 a little bit. So let's see if we can find the critical points. So let's go back to our notes, and the first thing I'm going to do is kind of make a nice big graph of what we just saw. And it looks like at 2, 3, 4, and it looks like at 1, 2. So let's see if I can do that graph justice. So we're going to come down, make like a point here, and go up. Okay, so here's x and y. And let's kind of set up our f prime bar underneath it, so as we find things in our critical points, we can label everything. So this is kind of nice to know, so that see if our calculus skills can tell us what our critical points are. So the first thing we're going to do is do the first derivative, and we're going to put it equal to 0 to find that. So this is the power rule. So I look at it, okay, so it's going to be 2/3. Don't touch the inside. And then we're going to subtract 1. 2/3 minus 3/3 is a negative 1/3, times the derivative of the inside, which is 3x squared. The 3's will now cancel, so I end up with f prime of x equals 2x squared x cubed minus 8 raised to the negative 1/3. And we're going to put this equal to 0, make our big T. So I have 2x squared equals 0, x squared equals 0 if I divide by 2 on each side, so take the square root of both sides, x is 0. So there's 1 point. And here I have x cubed minus 8 raised to the negative 1/3 equals 0. So I'm going to raise both sides to the negative 3 power. So that's going to make that a 1. So I have x cubed minus 8 equals 0. Move the 8 over, x cubed equals 8. Take the cube root or raise it to the 3rd power on both sides. So x is going to equal 2, which both of these make me very happy because we just looked and thought, well, it looks like this could be a point and this could be a point. So right now we're going to do our local max. We'll set it all up here if we see if we have a local max, and then we're going to see if we have a local min. So again, we know that the x values of our points are 0 something and 2 something, okay? And so let's look and see what we got here. First of all, I'm going to put here for 0 and come down here and put this for 2. And I'm going to go back to the factored one like we've been doing. So right here, this point right here, and we're going to put in something left of 0. So if I put a negative 1, this is positive here. But if I put a negative 1 here, this is negative, minus 8, negative. So this whole thing here is negative. Okay, which our graph, if you look at it, is right here, if you follow it down, is got a negative slope to it. So that makes me kind of happy. Now, if I go and look here, let's try 1. This is positive. I put a 1 in here. This is negative. So this is still negative here. So see where I don't see a change between these two? Now I'll go to the right of 2, so we'll try 3. This is positive, and then this is going to be positive now. So this turns positive. So if I look at it, there's really nothing here that is happening here. It's negative, negative. At first I thought there might be something there, but there's not. But I look here and say, oh, right here, this is negative, then positive. This must be a local min, which this does look like a minimum. Okay, so the local min is 2 something, and when I plug 2 back into my original equation, I get 0. So my local min is 2, 0. And the local max, there really is none, so we say none. Okay, now, a couple things on right here. I want to show you that. Please note that even, this is note, sorry, that this is a critical point. So 2, 0 is a critical point, even though it is a sharp corner. A critical point still exists even though the derivative, well, we'll say even though it is undefined, the derivative is undefined at 2, 0, at x equals 2. I just wanted you to note that, because you still can have a critical point even though the derivative doesn't really exist there because it's a point. All right, let's try another one. So now we have this wonderful function here. We have an actual graph for it. It's x cubed minus 3 times e to the x. So we're going to see if we can find the critical points. Look like this is a local min here. Looks like something's happening here, but we're not for sure. Okay. And first thing we gotta do is find the first derivative. But this is a product, so we got to do the product rule. So I'm going to do f is going to be x squared minus 3. F prime is 2x. G is e to the x, and the derivative of e to the x is itself, e to the x. So we're going to do y prime, or f prime of x, is f prime g plus fg prime, so I'm going to put the e to the x in front. And then when we get this, I'm going to do this in factored form. This is why I have you do this all year. This is a term here, and this is a term here. So I'm going to look and see what they have in common. They have e to the x in common, so I'm going to factor it out. So I have 2x plus x squared minus 3. Okay. Next is f prime of x is going to be e to the x. And I'm just going to organize this a little bit. X squared plus 2x minus 3. Now we're going to put this equal to 0 and see if we can solve for x some more. So I do this. Well, you know what? How about we see if we can factor this some more and get it even more factorable before we put it equal to 0. So I'm wondering if x squared plus 2x minus 3 is factorable. And lo and behold it is. It's x plus 3 times x minus 1 equals, now we'll put it equal to 0. Now this is a nice factored form, so I'm going to do a big T. Now e to the x is exponential, so it will never equal 0, but thanks for your help. Then this is going to be x plus 3 equals 0, so x is going to equal negative 3. And here is x minus 1 equals 0, so x equals 1. So we've got x equals negative 3 here, and x equals 1. So let's do our f prime bar here and see what we got here. So I got f prime, and negative 3 is about right here, and 1 is going to be right here. So I'm going to go to the factored form as we fill in our f prime bar because we're looking for critical points. So if I go to the left of negative 3, let's say negative 4, this makes this negative, and this is negative. Negative times a negative is positive. Do between negative 3 and 1, a nice one to use between that is 0. So this is positive and this is negative, so this turns negative. Go to the right of 1, let's pick 2. Positive, positive, so this is positive. So this makes it nice. Now we're going to do the first derivative test. This is positive, negative, so this is a local max. This is negative, then positive. This is a local min. This is nice. I like it when there's both there. Okay? So let's do this. Our local max is going to be negative 3 something. And our local min is going to be 1 something. Well, this one's not as nice to put it in, so I put it back in my original. When I did, I got 0.299 for my y. And it does kind of look that weird when you do negative 3. It's not up to 1 yet. Then when I put a 1 in here, it's way down here. It comes out to be negative 5 point, excuse me, that's a 5. negative 5.44. Okay, so we have a local min and a local max. That's problems 3 and 4. I'll have videos with the rest.